Hi, Anna.
Hi, hello.
Hi, welcome.
Good evening.
Thank you for having me.
How are you?
I'm good, yeah, I'm good.
Cool. Well, we're good as well. So I was looking at your profile before the session, and one thing stuck out to me that I wanted to ask you. And I don't want to ruin your first slide, so let's hope I won't. But I saw a whole lot of sessions and things you were doing that were related to data topics, and then all of a sudden, your topic of today is going into Terraform. So I was wondering where the bridge between those two came from.
Yeah, so I started off as a software engineer. So essentially, I did a lot of DevOps, a lot of infrastructure as code, and I am now a data engineering consultant. And part of my role, or a big part of my role, is I often get asked, what's the best solution when it comes to DevOps, infrastructure as code, for the projects and with the clients that I work with. And so that's essentially where this has come from. So I've worked with Terraform before in a previous role when working as a software engineer. But then I've taken those skills into my current role and used it with clients as well when they're looking for a really good, robust, easy to learn solution when it comes to infrastructure as code.
Great.
Cool.
So I'm really excited about your session. If you would share your screen for us, then we're ready to go. Here we go. So I'll add you to the stream. And then the floor is yours.
Okay. So hi everyone. Thank you for attending my session on Terraform. Essentially, we are going to spend the next kind of 45 minutes, 50 minutes talking about Terraform, what it is, and some of the best practices when working with Terraform. So what are we going to do specifically? What is Terraform? So for those of you who haven't used Terraform before, haven't heard of it, we will go through the basics essentially of what Terraform is and why it is so popular. Working with Terraform Cloud's service providers, so CSPs, working with other Terraform providers, and then best practices, again, when working with Terraform, so when working in production. So who am I? Essentially, I am a Microsoft MVP. I've got a strong background in, as mentioned before, in software engineering, but I specialize essentially in data engineering. And so I've been in this current role that I'm in for the last 2 years. I work for a company called Advancing Analytics. And essentially, I now consult. So I go into companies and I help them with their data engineering problems as part of a team within the current company that I work for. I've got Bachelor of Science in Multimedia Computing and a HND in Visual Communications. And as well as working with Microsoft, I've also worked with AWS, most recently Scala and Kafka as well. So contact and resources. At the top there, everything I'm going to show you, there is a Git repository. So you can go to that Git repository, there's a getting started guide, and you can play around with this yourselves. And that's just my LinkedIn handle and my Twitter handle as well. So specifically, what are we going to look at? We're going to run through the basics. We're going to look at working with a cloud provider, so in this instance, Azure. We're going to create a resource group, Postgres SQL database, a virtual machine, storage account, and essentially network. And then we're going to look at working with the Databricks provider. So this is an example of a provider that isn't a CSP. Essentially, it's one of the many providers that you get when you're working with Terraform. So we're going to look at creating, updating, deleting workspaces, clusters, and notebooks, and how to apply and enforce dependencies between resources, how to manage the Terraform state, and how to explore the Terraform deployment plan, and how to work with Terraform in Azure DevOps. So first things first, what exactly is Terraform? So Terraform is one of the most popular infrastructure as code tools. It's the third most popular cloud skill in demand for DevOps roles. So the first being AWS, then Azure, and then we've got Terraform. Terraform is the industry standard for infrastructure as code. So I've got that statement there. Whether it's true, jury's out, but it is essentially a very, very popular tool. So it is a very useful skill. But the question essentially is why, and we are going to go into that. So again, what is Terraform? It's a tool for building and changing and versioning infrastructure safely and efficiently. Terraform can be managed existing and popular service providers as well as custom in-house solutions. So it's very flexible. Configuration files described in Terraform, the components needed essentially to run single applications or your entire data center. So Terraform has this concept of write, so you're writing your Terraform, and then you hit plan, so you're actually hitting plan and seeing what's going to happen, so what's going to be created, what's going to be deleted, and what's going to be amended, and then this concept of apply, so you're actually applying those changes into your environment. And Terraform essentially fits into this DevOps model. So a lot of you have already seen this, a magical figure of 8 when it comes to DevOps. And we want to be coding, building, testing, releasing, deploying, operate, monitor, plan, and just going continuously around in that figure of 8. And essentially Terraform fits in that model when it comes to our infrastructure as code. And it's a really nice, easy tool to use. So talking about DevOps and infrastructure as code tools, some of the most common ones that you may already have heard of and used, we've got Azure DevOps there, Circle CI, Jenkins, Octopus Deploy, GitHub Actions. And on the infrastructure as code side, I'm sure lots of you have used ARM, and I'm sure lots of you have potentially been burned by ARM as well. When it gets complex, it can get quite difficult to work with. And then we've got Terraform there, and also Pulumi is a very popular one that's kind of up and coming. And finally, Azure Bicep, which is very, very new, but actually very similar syntax-wise to Terraform. So declarative versus imperative infrastructure as code. So before we dive deeper into Terraform, it's really important we understand the difference between these two and where Terraform fits in between these, and that helps us understand why Terraform is such a good tool when it comes to infrastructure as code. So declarative infrastructure as code is essentially what you see is what you get. It's explicit. It's more verbose, but zero chance of misconfiguration. It uses script languages like JSON, YAML, and XML. And essentially, the most common tools that we mentioned before that you potentially already heard of would be ARM templates, Azure Bicep, CloudFormation, which is AWS, and Azure Blueprint. And there at the bottom there, we've also got Terraform, which essentially will work across cloud providers, whereas the others there are specific to certain cloud providers. Imperative infrastructure as code, you define what you want, and the rest of it is filled in. So it's implicit. It's less verbose, potential to end up with broken code, broken configuration, essentially. So it's less. It can be less robust depending on who's using it. But it does have more functionality than declarative, and it uses a variety of programming languages such as Python, Ruby, and JavaScript. So essentially, programmers love imperative infrastructure as code because they can use their programming language of choice. So examples there would be AWS Cloud Deployment Kit and Pulumi, which you mentioned before. So Terraform is declarative, but it is imperative as well. It's got little bits of imperative functionality. So we've got here that HCL-ish Terraform language supports loops, dynamic blocks, and locals, and also complex data structures, so maps and collections. So it isn't completely imperative, but it is kind of, it's dipping its toes into it. So it gives you that extra bit of functionality that other declarative infrastructure as code tools don't necessarily give you. So what are the benefits of Terraform? So state management, Terraform has this wonderful state management where you can have that safety net. It always tells you what's going to be changed, what's going to be deleted, what's going to be added. And it's really, really, really easy to work with. So that gating for you, that safety net. It is cross cloud. Now we're all Azure fans. I'm a Microsoft MVP, but we do almost all of us have to dip our toes into other cloud providers every now and then. So it is great to have this tool that is cross cloud and essentially AWS, GCP, as well as Azure. So it solves the issue of provisioning complex infrastructure, so often encountered with other infrastructure as code tools. And as mentioned before, with tools such as ARM, ARM is brilliant, it's great until it gets really complex, and then you start to hit issues, or it becomes less easy to understand or less easy for somebody else to pick up. So it has a simple syntax, essentially. It allows for easy modularity. Terraform lets you define infrastructure in config and code. So what are the Terraform core components? So I've talked a lot about it. I've done like a sales pitch as to why it's so good. What are the core components that you work with when you work with Terraform? It's literally split into two areas. You've got the Terraform CLI, and that's essentially the same as if you're working with like the Azure CLI. It is a CLI that you work with to execute your Terraform, your commands. And then you've got the Terraform language, and that is where you actually define your infrastructure as code. That is your blueprint. So the Terraform CLI, as I mentioned, it is basically a suite of commands that you can work with essentially in your terminal. So for example, there we've got Terraform init and Terraform plan. So looking at it in a linear order, when you're working with Terraform, the first command you're going to execute is going to be the init, and that's the initialize. So you've got a fresh project, you hit initialize, and that initializes your project, which you will explore in more depth further down the line. You then can validate, so that will essentially validate your Terraform. So your infrastructure as code that you've written, it will validate it and make sure it's valid. You can then hit your plan that we talked about, and that will tell you what's going to change, what's going to be deleted. And then you can hit apply, so that actually performs those changes for you. So diving into the Terraform language, the syntax of Terraform configuration is called the HashiCorp configuration language, the HCL. And it's essentially meant to strike a balance between human readable and editable, as well as being machine friendly. So it's something that, again, anyone ideally could pick up and start working with, so more easily than other infrastructure as code tools. The main purpose of the Terraform language is declaring resources, which essentially represents the infrastructure objects. A Terraform configuration is a complete document in the Terraform language that tells Terraform how to manage and give collection of infrastructure. A configuration can consist of multiple files and directories, essentially. And finally, Terraform language consists of the following elements, and that is blocks, arguments, and expressions. And there's our first example of some actual Terraform where we're defining a resource. Where we're defining a resource, and there below you can see how it's described as a block, identifier, expression there. Okay, so now actually getting started. So actually looking at some real world Terraform and the CLI. First thing we want to do is actually talk about the structure. So you're going to write some Terraform. What structure should that be? Should you throw it all into one Terraform file, or should there be some sort of separation? So what we're looking at here is actually one of the standard ways of doing this. So we have a Terraform project at the top there, and then within that we have our core Terraform files, which we will explore, which is like the main, the output, and the variables.tf. And then we have our modules, and each module essentially is a different type of resource or a different type of grouping that you've defined. And again, in there you have the same files there. So yeah, we've got our README and the main.tf, which is so it's the resource configuration for the infrastructure. The output, essentially outputs the variables. The variables.tf, that is what it says on the tin. It stores your variables. And then we've got a .tf vars file, and that's essentially where we store all of our values that we want to pipe into our Terraform, into our CLI, which would normally be things like like our secrets and our SQL connections and things like that. And then we've got locals, and they're just essentially local variables that we work with. And data.tf is essentially where you store components that you're not actually writing the Terraform for them, but you want to be able to grab them. So that could be a resource group, that could be a database, and essentially if you're creating data resources, that's where you can shove them. So in the repository that I've shared with you, this one here, we will be looking at this essentially folder structure here. So we've got an Azure folder and a Databricks folder, and I've expanded it there, and we can see we've got Terraform, and then we've got a dev folder and a modules folder. So hopefully you can see that. This is essentially it here in Visual Studio Code. Now I'm assuming you're all familiar with Visual Studio Code. If not, it is essentially a really popular IDE when coding, working with other things such as databases and things like that. So essentially what we have here is exactly what I showed you in the screen share. We've got an Azure folder and a Databricks folder, and then we've got our dev folder here, which is our environment folder, our main.tf, provider.tf, which we essentially mentioned before. So talking about the environment folder, what exactly is that? I've skimmed over it so far. Essentially, the environment folder is exactly what it says on the tin. It is the environment that this particular instance is referring to. So this is our development environment. If this was a real world scenario, we would also have, say, a test folder and a production folder, and they would have the same, essentially the same files in there, like the main.tf, the provider.tf, the vars.tf. And that Terraform.tf, as I mentioned before, that is where we're storing all of our values that we want to pipe into our Terraform. So actually exploring these files and what they do. Again, you could just throw all of your Terraform into one file, but that isn't best practice, and I wouldn't advise doing that when you're actually working in production. And this is a big part of this talk, is actually talking about some of these standards that we adhere to make sure that we're doing these things right. So this provider.tf, essentially here we've got a little snippet from it. And what do we have? Well, we have some Terraform variables there. And at the top there, we're defining, I'm going to work with the Azure RM provider. So that's the Azure provider. That's the cloud instance that I'm interested in. So you're defining what cloud provider you're going to work with. And you need this, as this is one of your first steps when you're working with Terraform, is actually defining which providers you're interested in. And then at the bottom there, those variables, we're just piping in what subscription we're going to work with, what the client ID is, what the secret is. So that's the service principal, and your tenant ID within your Azure cloud instance. So the main.tf is your entry point. So essentially, whenever you hit a Terraform command, say Terraform plan, a Terraform apply, it will look for this file. So if you're running in the terminal, you make sure you're in that file folder structure in that location. You hit Terraform plan, and it looks for this file, and it executes essentially your Terraform based on this. It is your entry point for all of your Terraform. And what we have here is, and we'll talk in more depth about state in a second. Essentially, this is referencing a external state file. So your state file can be local or it can be remote. And this is where we're actually referencing a remote state file. And that state file is stored in a Azure blob container, essentially. And then here we've got our Terraform modules. So I talked about we've got modules that break down into different components, so different areas. So essentially, we've got examples here of where we're breaking it down into resource groups and storage accounts. And that is defined in our main.tf. So we're saying I'm going to work with the resource group module and the storage account module. And then it's useful to note there, with Terraform, you can define your dependencies really easily. So we know that we're creating a resource group, and then we want to put a storage account in it, we need to make sure that that resource group is created first, otherwise everything is going to blow up. And this is just the syntax to do that. We're just saying I'm dependent on that resource group module. So you add that in there, and Terraform will know to always create that resource group or update that resource group first. So variables, as previously mentioned, Terraform essentially has this concept of variables. But how you populate those variables, there's different ways. And so it's really important when you're working with Terraform, understanding the order of which this is actually prioritized. And I say this because I myself have been burnt, and I know people that have been burnt when it's looking for the values in the wrong place. So priority-wise, it will first look for environment variables, so environment variables on your system, or if you're in DevOps, on the agent. And then it will look for the TF-vars file that we saw before in the repository and in my screen grabs. And if it's present, it will work with that. And then it will look for tf-vars.json file if present, and then any auto.tf-vars files. And finally, and I do use this one, when you're running your commands in your terminal, you can just pipe those variables in there as well. And I quite often do this when working in DevOps, just so I can pipe in the secrets that I've grabbed from my key vault. So looking at the actual Terraform syntax itself, here's some examples here. We're defining our subscription ID, our client ID, and our client secret. And it's worth noting here, essentially, we've got marker sensitive here. What does that mean? Well, we don't want Terraform to output into our terminal at any point our secret. So we're just telling Terraform here, this is a sensitive piece of information. So don't ever output this when you're running essentially anything, which is obviously super important. So modules, what modules do we actually have? We have, as mentioned before, we are going to be creating a PostgreSQL database resource group and storage account and virtual machine there to work with our network. So we have a module per one of these. So essentially, we've broken this down per resource type, but that is open to interpretation as to what suits you best in your environment. So modules, the resource group module. So this is just a little snippet, and it's easier to show you this in this slide. I don't want to do death by slides, but it's easier to show you the little snippets here, and then we'll dip back into the code again. So we've got a snippet here where we're defining a variable, a resource, and then we're outputting. So we're working with our prefix there. So that's just a little bit of sugar there that we can work with to build up the name of our resource that we're creating. And then we're outputting those values. And that is really key because we want to create this resource group, but then we need to work with it in modules further down the line. And working with output variables is the way that we can easily do this. And now we have our storage account module. So here we've got essentially using those data tags. So we talked about the data tags before. We've got an example there above this resource tag. So we're going away, grabbing that resource group, and that's being pulled in from that output variable that we looked at before. And then we're able to use that directly in our actual storage account here. So there's no magic strings here. There's no passing in a variable with the name of the resource group. We're actually grabbing it as a data object and then populating that via that object. So there's less room for error there, especially when you're first working with Terraform, where you've got quite an elaborate array of Terraform. You've got a massive set of infrastructure. It does make your life easier and just catch errors a lot quicker for you because you're actually working with an object and not any sort of magic string. So yeah, variable from previous module there. And then our PostgreSQL module. So again, variable from the previous module, using our data resource group again, and and then a password coming from a variable. So we've already covered variables and how they work. That's just an example where we're then parsing that through down to the Terraform so we can work with it securely. And then our module on the virtual network, a little bit more complex. So as you probably notice, this is slowly building up and getting bigger and bigger, but hopefully this is making sense. So we create a network, we create a subnet, and then we create a network interface. And essentially these are all, this is building up your picture step by step. You're creating your network, and then your subnet references your network, and then your network interface references your subnet. So you've got a chain essentially of association there. So they always get created in the correct order. And then finally, our virtual machine here, we're then referencing our network interface. So hopefully you can see that how that all essentially chains together. So it looks like a lot of Terraform, but essentially when you break it down into different resources, it's pretty simple. So running the CLI commands, so we've gone through a load of actual Terraform itself, but now we want to, and that's our infrastructure defined, that's our blueprint, but now we want to actually run the CLI commands. We actually want to do the compute. We actually want to deploy this. Now, again, we're going to go through the concepts of all the core commands in a linear order. So you'd initially run the Terraform init to initialize, and that would go away and get all your providers and build that initial state file for you if it's needed. And then we've got validate, so that will validate that all your Terraform is correct. Then you hit plan to get your Terraform plan, and then we hit apply. So looking at that Terraform init, now we are going to dip into the actual solution again. But initially, just looking here, this is where I've run a Terraform init. We've had a successful initialization, and it's happy, and it's told us it's gone away to get our Azure RM provider. If this didn't work, you'd have the red writing of doom. So if we step back into the code again. So what we've got here is I've got a terminal window open in Visual Studio Code, and if I run Terraform init, and I haven't covered how to install Terraform here, but essentially there's lots of information out there if you go onto the main Terraform documentation as to how to install it and start working with it. So if we're in Terraform init, exactly the same sort of output. We can see it's happy, it's gone away and got the provider we wanted. So it's looked at that providers.tf and said, okay, you want to work with Azure, so I'm going to go and get it for you, and it's happy. Admittedly, I did try this earlier because I don't trust the demigods, and so we already have what it creates for us, which is this Terraform folder, and that's where it stores all that info. So the provider that we've downloaded is in there. And it will also, because we are working locally, not remotely, when it comes to the state, it's also created as a terraform.tf state file. So moving on to Terraform validate, exactly what it says on the DIN example here. You run Terraform validate, it tells you it's successful, great, wonderful. What happens if that actually falls over? Well, I've got an example here where I've deliberately named a variable incorrectly. So we can see there we've got name equals var.resource_group_NAM, which should have been name. And essentially because I've missed the E off the end, it throws as an error. And this is a really easy kind of mistake to make when we're batting out loads of Terraform. So it's really great to have that functionality in there that will actually validate our Terraform and not hit us in the face further down the line. So sorry about that. So if we were to run Terraform validate now, success, the configuration is valid, which is exactly what you want. I would have panicked if it would have said that that hadn't succeeded. And our Terraform plan we're now moving on to. So essentially our Terraform plan, as mentioned before, this tells us what is exactly going to happen when we are actually trying to deploy our infrastructure as code. So when we run Terraform plan, it will essentially say this is going to be created, this is going to be deleted, this is going to be updated. This already exists, which is what you don't want to see, but it happens. And essentially on this first slide here, I've run Terraform plan is trying to acquire the state lock, because the state does lock when someone is running Terraform commands, which is exactly what you want. You don't want two people doing changes to your infrastructure at the same time. And here, this is an example of where I've talked about piping those variables directly into your terminal rather than, say, work with a TFRs file. It's literally, I've performed the Terraform plan. It's been unable to find a value for that variable, that Postgres password. So it's prompting us to enter a value, and we've just entered my password in there. So here we've got an example of running the actual Terraform plan and an output, and it's telling us at the bottom there, because that may be a little bit confusing to us, it's telling us, it's saying 0 to add, 1 to change, 0 to destroy. So that's a really good example where the Terraform's already been run before, the infrastructure's already been created, but here we're making a small change. And above there, it's telling us I'm actually going to essentially make a change to the PostgreSQL database. So moving into our code base again, I'm going to run Terraform plan. As you can see here, this is a little bit more easy to read. Essentially, we can see a really, really big plan here. So this is greenfield. This hasn't been deployed before. So we've got lots of green X's because it's telling us, I'm going to create all of this stuff for you, which is quite a lot. And so right at the bottom, saying I've got 8 to add, 0 to change, 0 to destroy. So it's very greenfield. It's just, this is the first attempt. It's going to go away and try and create all of this. But for some, that's not very easy to read. It's not necessarily readable for everybody, especially if there's a lot going on. There is tooling out there when you're working with your Terraform plan. And we've got an example here where we're able to upload a JSON file that we can create as part of the Terraform plan command. And essentially, we can work with that JSON file, upload it to tools such as this, and actually visualize that plan. So one second. Bear with me 1 second. Computer's not playing ball. Right. So hopefully you can see that okay. So we've got the Terraform visualization tool here, actually in the browser. And what we can do is we can actually click on these components. We can minimize them, expand them, and actually get more details as to what is actually going to happen if we were to then move on to our next step and do a Terraform apply. So yes, moving on to our Terraform apply. So here's our example output, as I've shown you before with the other commands. It's telling me essentially I've done a Terraform apply, and this is just saying apply is complete, resources added none, 1 change applied, 0 destroyed, and happy text because it's green. What happens if it's unhappy? Well, here's an example. It gives us basically, this is a really good example where we've tried to give it a password, like that password I showed you before, and it doesn't conform to the standards. And essentially that's been thrown back to us. And we've got a very quite a readable, understandable message there, just saying the password does not meet policy requirements because it is too short. This is super useful when we're deploying lots of different infrastructure, that we can get these readable messages back and immediately understand what that problem actually is. So again, computer not playing ball, so yeah. So if we run the Terraform apply here, this is going to think for a little while. And we can hit, it basically prompts you to say, do you actually want to do this? You hit yes. And it will go away and create all of that for you. And now just a little bit conscious of time. Essentially, trust me, it will go away and create it all for you and give you a nice green response afterwards that is happy. What we're interested in is the end results. And essentially, this green grab here shows us what it will create. This is what we'll get at the end of it. We'll get our resource group and we'll get all of our resources deployed in that linear order within your resource group. So when you get a massive amount of infrastructure, it's nice to be able to visualize it, right? It's like to be able to see how it all hangs together. And Terraform does have this graph command. Now, I appreciate this isn't very easy to read, and I'm not expecting you to be able to understand this from this instance. But trust me, if you run that command at the top there, that Terraform graph, you can output this file and then open it, and it gives you a diagram such as what we're seeing here, which essentially shows you how all of that infrastructure in your Terraform hangs together. So again, I'm going to skip over that just because I'm conscious of time, and then move on to that Terraform state file that we've been talking about. This is an example of the state file in a blob store. So this is in Azure in a blob store. And the advantage of this, the big advantage of this, is that everybody points to the same state file. So that locking that we talked about with the state, essentially, if you've got two devs working side by side, both working on the same infrastructure, both trying to deploy, you can make sure that they're not trying to do it at the same time and breaking each other's stuff. And so if they're both pointing to the same state file, one will lock it as if they're the first person to hit Terraform apply, and that will stop the other one from being able to start trying to deploy stuff at the same time. So it's a really good safety net there. Also on that note, Terraform will tell you if things already exist in your environment. So if you're trying to create something and somebody's already manually gone into Azure and created it, it will throw you that error back and tell you you're trying to create a resource that already exists. And in that instance, you can actually import that into your state file, which is super useful. So I haven't got enough time to cover that in this session, but that is a really useful feature. At the moment, it doesn't write the Terraform for you, but that is in the pipeline apparently, that would be a feature. But essentially, yeah. This doesn't have to be for greenfield projects. This can be for existing projects that you're moving over to Terraform, and you can import all of that stuff into your state file and map it to your Terraform, and then run your checks to make sure everything is okay. Yep. So yep, and you can explore it using the Terraform state command. So if we did Terraform state list, it would literally list everything in the state file for you in your command line, and you can start exploring that. So again, running a little bit short on time, so just skip over that. But this is all in the repository, as mentioned. So you're welcome to explore that and start playing around and message me if you've got any questions. But the next question is how to use in DevOps. So I showed you how to run these commands locally, and that's all nice, but we want to use this in our DevOps environment. We want to just kind of press a button or wait for it to be on a schedule and just let it do its thing. So using Terraform in DevOps, and particularly using it in Azure DevOps, it is fairly easy. There essentially are some tooling on the marketplace that you can use to create yourself some Terraform tasks so you don't have to write the pure CLI commands. Some may find that easier, but others find it easier if there is actually a task they can work with. And what we're seeing here is where I've created Terraform demo for CD pipeline and a Terraform demo CI pipeline. The difference purely being the CI pipeline just goes up to the plan stage, and the CD pipeline will actually do the apply. And with some clients with the CI pipeline, we have outputted the results of that to a Teams channel so they can react if there are differences in the plan that are unexpected. So that would run on a daily basis. And again, that will pick up if anyone's been messing around with the environment manually, so gone in and started creating and messing around with stuff, it would essentially pick up on that for you. So again, how to use in DevOps. So this is an example in a DevOps pipeline in Azure DevOps. So this is our YAML. So I am assuming that everyone's familiar with this. There's lots of documentation out there. If you're not familiar with YAML when working with Azure pipelines, we are essentially defining our job of apply. So that's a Terraform apply. Grabbing secrets from the key vault in a key vault task, and then we're able to pipe that into our Terraform task. Again, this is a marketplace task, so this is something I've grabbed off the marketplace, installed in my DevOps environment, and I'm able to create these Terraform tasks and then pipe in all of the variables that I'm interested in. So again, marketplace extension, some of you out there would be like, yeah, I'm okay with just creating a bash script and piping in all those variables manually. I'd rather use a bash script, it's more transparent perhaps. And this is just an example of just working with the vanilla Terraform CLI. So you don't have to use the marketplace tasks, but they are super useful. And then, yeah, we're working with our key vault secrets. Okay, and this is essentially our pipelines in the real world. So our CI pipeline, which is running successfully, it wasn't for me earlier. We can just see some success statuses there. And we've got it in different stages. So we've got our init, validate, and apply, and those are essentially our commands as we've gone over before. Our init, our validate, and then our apply there for the CD pipeline. Okay, so we have covered the Azure provider, and we've gone through some best standards, best practices, and we have talked about DevOps and working with Terraform and DevOps. What about the other providers out there? Well, not the cloud ones, but what about the other providers out there for different tooling? And a great example is the Databricks provider, because it is really popular. There's a lot of movement behind it. It's a great example essentially just of a provider that isn't a cloud provider that would enrich your environment. Even though you're working with Azure and that's all you're interested in, you'd still potentially, if you're working within data realms, work with providers such as this, a Databricks provider. So looking at some Terraform again, we are referencing our Azure provider, and then we can reference our Databricks provider there. And so they're going to work hand in hand. On Azure, we're going to create a resource group, and our Databricks provider, we're going to use it to create a Databricks instance. And again, this is all in the GitHub repo that I've provided. So we're going to create a workspace. So there's our resource group that we're creating with the Azure provider, and then we're creating a Databricks workspace using that resource group that we have created previously. And now we want to create our Databricks secret scope. And so exactly as you've seen before with our Azure provider, we're creating resources, we're telling it what resource type it's going to be, and then we can pipe in our variable values, exactly the same with any provider. So we're creating a secret scope, a pat token, our secret to work with Databricks, and then we can create our cluster there. So quite a lot going on, but still quite easy to kind of break down and understand what's going on. We're creating a cluster, we're defining what libraries we want to add in there. We're saying we're going to have PyODBC as a library, and essentially adding some tags. Oops, sorry. Sorry, my voice is going now. And then also we've got Azure attributes there. And then essentially we are working with Databricks Notebooks. So we want to upload some notebooks, and essentially what we've got here is a base encoded path to where that Databricks notebook is going to be. And this is our end result. So essentially, this is going to create us a Databricks instance in the resource group that we have defined. So 2 providers working hand in hand to achieve that infrastructure as code dream. And again, being conscious of time, I don't have time to demo it, but the code is there, so you're welcome to have a play around with it and reach out to me. So moving on to our summary. Essentially, Terraform is the 3rd most popular DevOps tool. Providers aren't just restricted to CSPs. Terraform language is richer than alternatives. Managed lockable state allows infrastructure as code to be managed without conflicts or resources essentially disappearing. So essentially without things accidentally being deleted. It provides that gating, that security for you, especially if there's a lot of you working in a team or working towards deploying infrastructure as code, working with your current architecture. So the CLI commands are fairly easy to learn. So it's all out of the box. It's all part of the Terraform package. You learn Terraform init, you learn Terraform plan, you learn Terraform apply. And though there are lots of other commands out there, essentially, once you've learned those 3 and Terraform validate, you can get going with Terraform and start playing around and understanding how it works and feeling comfortable with what it's doing and what it's deploying for you. It is easy to integrate with DevOps. It literally is a CLI. So as long as your DevOps environment has access to that CLI in its agent, you can run those commands in a vanilla way, or you can do it using, as I showed you, those out-of-the-box tasks from the marketplace. So Terraform Plan provides valuable access and visualization of potential changes, and I can't enforce that enough of how useful that plan is and how easy it is to essentially explore it. Essentially, if you are interested in Terraform, and this is a shameless plug, I am doing a day workshop at SQLBits this year with my colleague. Essentially, it is data focused, but it will teach kind of the ground up, working with Terraform, the do's and don'ts, the gotchas, essentially what we've learned using it in the industry. Essentially, it is a workshop. It is paid for, but it is worth doing if you're interested in learning a little bit more about Terraform. So yes, thank you very much for listening to me. I hope you enjoyed it. Again, there's the code base. Download it, have a play around with it, and those are my my handles. So that is my LinkedIn handle and my Twitter handle there, and you're welcome to reach out to me.
Perfect. Thank you so much. You really demystified Terraform for me. It was very, very nice session.
Thank you.
Yeah, thanks so much, Anna. It was really nice. I have a whole bunch of questions here. So if you're okay, I'll just fire away. First one is you showed the decision tree Terraform follows when it reads variables in. And I was wondering, where do the autovars files, where would those come from?
Which vars files? The TF vars?
There was like a star auto TF in there.
Yeah, I personally haven't worked with them, but they're on the list of the priority of the priority it takes, and they're right at the bottom. And so far, I've not had a reason to work with them. So I don't know the answer to that one. But I've worked with the rest of them. So I've worked with like the CLI when actually piping those variables in the TF vars file, and I haven't had a reason to work with the other.
Okay. I have another question from Esther here, and I can put it on the screen. So is the Terraform graph output based on the Terraform state file, or does it check directly with Azure ARM what was created for you?
So it's based on, it essentially is based on your Terraform. So it looks at the Terraform in your solution and it draws a graph for you.
You had another question, Roland, I think.
Well, yeah, this is a general wonder for me. Do you have any experience when Azure has new functionality? How long it takes that that functionality is available in Terraform for new types of resources?
I haven't had any experience of things being missing, but what I can say is with that Databricks provider, definitely use that over anything that's in the Azure provider for Databricks. There's a lot of movement around the Databricks provider, and there's a lot of new features being added all the time. So that's a really good example where you've got a separate provider which you can work with to make your infrastructure even more awesome. So.
Okay, cool. Thank you.
Yeah, another one. You said that when you use outputs from other resources, that it handles the ordering of the deployment for you. So then when we use depends on?
So you're using the outputs. Perhaps I worded that a little bit backwards. You have to use a depends on for it to be able to work with your previous module that it is dependent on, but you can pipe those variables in to the next module from the outputs of the first module. Does that make sense? So the depends on is still key, but it will grab the output variables from the previous module. So essentially, if you've defined a resource group and you want to grab the ID, because you've got the depends on, it's been created, and then you can grab that from the output. Does that make sense?
That makes sense. Thanks.
Yeah.
I think I have another one from Esther. Yeah, I think this is a nice one. Do you see a lot of usage of Terraform in hybrid infrastructure? So I think what she means is using Terraform and like one Terraform, what was it? Apply to deploy to two cloud environments at the same time.
I haven't used it to actually deploy to two cloud environments at the same time. I've used it in conjunction for different cloud environments. So you're working, say, with an S3 bucket in AWS that you're going to then pull a load of data into Data Factory and put into a data lake. I've worked with that sort of environment, and then you would have those separate bits of Terraform to work with that. So you're able to use the same infrastructure as code tool across the board, regardless of it being different cloud providers. But I haven't used it trying to work with two different CSPs at the same time. So it's an interesting question.
Yeah, I have one. This is a personal one. This is one I always struggle with a bit. So if you have two applications, for example, simple example is two web applications or two app services in Azure that need to use the same key vault, or something is shared between the two. Where does that shared part end up? Because in my mind, if both of them have that in their template, then they're going to be trying to deploy the same thing, and that doesn't make sense.
Yeah. So so with a key vault, I potentially keep that in a separate solution because it is used in more than one resource, and then we'd work with those data tags to pull that key vault into those different Terraform solutions. So we'd make sure that our key vault is already created and updated accordingly, and then we'd have essentially, if we're talking about DevOps, our pipelines that then would work with any changes for those two different web apps that work with the same key vault, and they'll have those data tags. So if the key vault doesn't exist, it would, when it tries to execute that data tag, it's going to come back to you and say, this doesn't exist. I tried to find it and it's just not there in your environment. So that's a nice, easy error that you can work with straight away. Whereas if you're working with magic strings, it's not necessarily going to be the easiest to debug, or it's not going to be as easy because you'd have to then manually go away and say, well, actually, does this exist? Why isn't it working? And so, yeah, working with the data tags so you've got the objects is the way forward, I think, with that.
Okay, thanks. I'll use that tomorrow.
That makes a lot of sense. Yeah, thank you.
Yeah, so one more from Esther, because she went all out in the chat. So here we go. What's your experience?
And we did that already.
Oh, that's
that
the
was...
wrong one. Sorry. This one. So I'm trying to parse it myself quickly. So if you use templates for hybrid environments, would you have to have provider-specific settings?
So you can get a little bit mixed up with namespacing. So with the Databricks versus the Azure had a Databricks namespace, and that was a little bit fiddly. And my colleague had to find a workaround for that, because trying to work with them hand in hand could get a little bit tricky. You needed to make sure the namespacing wasn't getting mixed up. So you can hit little gotchas like that. But personally, it's only been kind of minor hiccups. So I've not hit anything that's been a showstopper yet.
Okay, well, that was all the questions I had and all the other people in the chat had. So I want to thank you so much for giving us this session, because it really cleared up a lot of what you said, Roland. It demystified.
Yeah. It really clarified some bits I was not sure on for Terraform, because I've used ARM templates almost too much, and Bicep. I love Bicep, but I have not done that much with Terraform. So there were some missing bits in the Terraform ecosystem, but you clarified it very well. So thank you so much for being with us and presenting such a wonderful session.
No problem. Thank you for having me.
Thank you.